Cooking noodles, is that a chemical or physical change? Excellent, excellent. And I will remind you guys coming in that today is not September 17th. Today is September 16th. And we are going to be talking today about chemical properties. And welcome, Sky. And welcome, Gabriel. Hello, hello. And we are, maybe we jumped into the future. Tomorrow you will see that same box with tomorrow's date. So I will remind you to park it. You guys do such a great job participating in class. I think y'all are the best participators of my day. So good job on parking it there. And good job on not sharing personal information and being respectful and courteous and keeping your chat box on topic. And moving on. So today we are going to look at chemical properties. We are finishing up standard SPS 1C, which is using the periodic table to predict properties. So today we're going to finish by identifying chemical changes, and most prominently, we need to be able to differentiate physical from chemical changes. So, still working on the whiteboard. Okay, so tell me what you remember about physical properties, physical changes. And you can minimize me or move me around if I'm in your way. I would love to see something from everybody on the board. So we've got some good stuff going up here. The cat has greenish yellow eyes. She does. That is Umbra. She's actually sitting right here on my desk. Lustrous and malleable. Those are definitely physical properties. They do not change the identity, can be observed, and doesn't change the identity. As she heard her name, there's her tail. They are measurable. Chemical changes can be measurable as well. So I'm not sure that really differentiates, but physical properties are measurable. But I think chemical ones are too. But, you know, this is just what we're remembering. So pretty good job there. All right, so let's see how we did. I think we got this, that they can be observed, that they do not change the identity. So how is that going to be different from the chemical properties? So what do you know, what do you think we're gonna get from our lesson today on chemical properties? And hello, Avery, welcome. And Hannah T, glad you made it in. Any examples? I know you guys had some examples back at the beginning of class. Okay, burning or rusting. The identity is going to change. Setting fire. Food rotting, fireworks, paper burning. Excellent. Oh, how things react to other chemicals. That could probably even go over under information because it's not as specific. Got reactivity. Ooh, thank you. Baking. Cool. And I used to be able to tell when you were typing. I haven't figured out how to do that yet, but I bet there's a way somewhere. So I'm going to close this up and move on because I don't think we're adding anything else. Nice job with this, you guys. Yeah, on the board. I can't tell when you're writing on the board. I can tell when you're typing in the chat. All right, so chemical properties can be measured only by chemically changing the object. And hello, Kaher. Flammability, oxidation, toxicity, heat of combustion. Oh, so cute, so cute. All right, so what is oxidation? Any idea? What is toxicity? And sorry guys, some people are having a hard time hearing me, and so I was just sending them some notes about refreshing. Okay. All right, so the level of toxic, okay. What about oxidation? Any ideas? All right, so we're gonna need the lesson today for sure. So I did want to show you this because I like these graphics of how to differentiate. So changing the identity. And so here are some examples of the chemical ones and how they react with air, acids, base, waters, or other chemicals. Yes, Sky, that's fine. No worries. And I did want to mention that, you know, we talked about physical properties. They are actually split up into two separate categories. We have intensive and extensive. Yeah, I will hope you feel better too, definitely. So intensive are things like things that don't depend on the amount of something you have. Like if you have an ice cube, it freezes at 0 degrees. I'm sorry. If you have an ice cube, it will melt at 0 degrees Celsius. If I have a giant elaborate ice sculpture that's 6 feet tall, it will still melt at 0 degrees Celsius. So that's intensive. It's independent of the size. There are extensive physical properties that do depend on the size, like the mass. The mass of an ice cube is different from the mass of a giant ice sculpture. And so that's going to be your extensive physical property. Any questions about the difference between the two? Intensive is independent of size. Best way to remember that. But I don't think you'll see that. If you do want the link, it's on the slide down there at the bottom. And I've released this, so when you get into the breakout room, you can take a look at it on the whiteboard. And while you're working through your lesson, this is what you want to look for. Those indicators, the 5 indicators of a chemical change. And then what is oxidation and what is toxicity. And once I move you guys into the breakout room, I will put this slide in there so that you can check back to it as you work on today's lesson, chemical properties. So anytime you are ready, give me a green check and I will scoot you into the breakout room. All right, welcome back from your work session. So go ahead and fill in what you learned on the board. Interesting. Where is my chat? Oh, there it is. All right, so indicators of chemical change. We have the formation of bubbles, production of an odor, we've got change in energy, change in identity, formation of a solid. Excellent, excellent. What about oxidation and toxicity? Oh, and I'll mention over here with the change in energy, either you can give off energy, causing your surroundings to heat up. That's called exothermic. And if you absorb energy into the chemical reaction, the surroundings get colder, and that's called an endothermic reaction. And the identity, I would put that as like the overarching indicator of a chemical change. So I would put that up at the top. Oops. And I don't know if I did that. Thank you, whoever moved it back. Appreciate it. Oh, no worries. That's why I have the eraser locked so we don't lose anything unintentionally. The first time I tried that eraser, I erased a lot of things unintentionally. All right, so oxidation and toxicity. Let me put those up then on the board. So we got all of the indicators, except for oxidation. That is any chemical reaction where the electrons are moved. And the substance that gives away the electrons, that's the one that's been oxidized. The other one has been reduced. It's called a redox reaction, reduction and oxidation. So if you go into chemistry in college, you'll learn all about redox reactions. But for us here, we'll just go with oxidation is a chemical change. And toxicity, that's biological harm that's caused by a substance. All right. Oh, the formation of a solid. I've got a little video to show you real quick here. I know we're almost, well, maybe I'll show that tomorrow because I really want to talk about the food. And, well, 55, right? 55. We got a minute. It's only a minute long. So this is in a liquid. So it's called aqueous solutions. And so the AgCl there is the precipitate. That's the white stuff. And that's our solid that's being produced. And so it mixes those first two chemicals together. And that's silver sulfide that precipitates out that brown stuff. And this one's actual speed. A lot of them are slowed down, but this is the actual speed there. Yeah, so it's like mixing two liquids together and then you get this solid. I love their rain sounds for precipitation. And this is a copper compound, that's why it's blue. And that's the end. So just some really pretty precipitates or formations of a solid from chemical reactions. And sometimes like I'll have an old chemical bottle or something and there's some solid particles at the bottom of it. That tells me that there's some chemical reaction that has happened in there and it's probably time to get rid of whatever that is rather than use it. Okay, so I wanted to take a look at something that would affect you personally. And so have you all ever had food go bad in the fridge or steel chips? Well, you can blame that on air and oxidation. So I'll give you a sec to read this unless someone would like to get on the mic and read this. Cool. All right, Reliable, go for it. Awesome. Thank you so much. And this came from UNL, and that's a direct quote from their website. Yeah, you can hear some noise along with your mic. I don't know if you were typing or what. Oh, yeah, I don't know if something, okay. Yeah, I was gonna be impressed that you could type and talk at the same time. Maybe. All right, so what can you guys do to keep air away from your food? Yes, seal it tight, so keep your container sealed. How full should you make your containers? Yeah, eat it quickly. Oh, all the way full. The more you can fill up a container, the less air that's in there, and then the less reaction that can occur. And like something like cake batter or pancake batter that I might keep for the next day, I'll put saran actually on the batter surface so that it's completely sealed and cannot reach the air. So let's hope that helps with the hearing. Sure, Zuleika. And you guys have access to the PowerPoint. If you click those three little lines on the whiteboard and go to my presentations, then you can look at it on the whiteboard, or you can download it as well. Okay, put it here on my list. Okay. So what about stuff in your pantry? What do you do to keep your chips from going stale? Yeah, you put a clip on there, and what do you do before you clip it? Definitely fold it down tight. If you have a vacuum seal, you can certainly use that to keep foods fresh longer. And yeah, but the main thing is the cooler, the better, because then things react more slowly, and then keep the air away. Yep. All right. Yep. And this is Rocky. That's Umbra's sister or brother, Umbra's brother. Okay, last thing to do. Let me put this on the whiteboard and let you guys circle all the chemical changes. Oh, good. There you go. We got the third one. Just cutting bread. Cutting bread, probably not. But cooking the bread, yes. Baking the bread, the bottom one could be construed as baking the bread, and that would definitely be chemical as well. But nice job, nice job. You all know the difference. So, wow, I finished really, really well. And hello, Samaya. Glad you made it in. So if you guys have any questions, please put those in the chat or pick up the mic. Otherwise, I will see you all tomorrow. Keep challenging yourself and have a great afternoon.